So when we are looking at today's lesson, the key for today is to not pay a ton of attention to labels, but more importantly, paying attention to using those labels to help us set up our proportions. So for example, on the very first one, on a Wisconsin road map, Kristen measured a distance of 11 and 1/8 inch from Madison to Wausau. I don't know if that's how you pronounce it, but that's how I'll pronounce it. The scale of this map is 1 inch to 13 miles. What is the actual distance between Madison and Wausau to the nearest mile? So the very first thing that you would want to do is you're going to use this to start setting up our proportion. So we've got 1 inch to 13 miles. And so then you can think about this. We are given the 11 and 1/8 inches. So 11 and 1/8 inches. And then we don't know the miles. So as long as those labels, inches and inches, match up, we don't have to do any sort of converting or anything like that. We just have to make sure that we put them in the same spot or the corresponding spot in our proportion. And now we can just go ahead and cross multiply. So we've got 13 times 11 and 1/8. So let me type in 11 and 1/8 here. Just give me 1 second. Times 13, which gives us a value of approximately 144.625 equals, and then the other way is just 1x. So remember to make sure that we round if it asks us to, which it does. So to the nearest mile, it is approximately 145 miles. So we can use that label there at the end to go ahead and answer the question. So if we take a look at the second one, we're not actually going to do the math behind the second one, but what we are going to do is just talk about how you would go about doing this. So when you look, it says to find the actual distance between City Hall and El Centro College. So what you would want to do is you would want to figure out how far this is, and then how many of those go from here to here. So you would have to figure out, if you look, we can kind of eyeball this. I know you can't do this on your screen, but you've got 1, 2, a little bit less than 3 of those. So it's going to be a little bit less than 900 meters because each one of those is approximately 300 meters. So we were just going to talk about that. If you had a ruler, obviously you could do that more precisely, but that's kind of the general gist behind that. So let's take a look at this second example. Lady Liberty holds a tablet in her left hand. The tablet is 7.19 meters long and 4.14 meters wide. If you made a scale drawing using the scale 1 centimeter to 0.75 meters, what would the dimensions be to the nearest tenth? So let's set up the original. We've got 1 centimeter to 0.75 meters. And so notice it says, what would the dimensions be to the nearest tenth? So we've got 2 different dimensions going on. So let's just start with one of them. So that 7.19 is the meters. So that's going to go down here in the meters. And then we don't know the centimeters value. So what we would do now is go ahead and cross multiply. So 7.19 equals 0.75x. And so then to solve, we would go ahead and do 7.19 divided by 0.75, which gets us a value of, and notice it does say to the nearest tenth, we've got a value of approximately 9.6. And again, your unit, since we're talking about the scale model, is going to be the centimeters. All right, so take a minute on this video and go ahead and figure out what would the length, or excuse me, what would the width be? What would the width be? So as you are looking at this, hopefully you're doing the same type of process, and you would end up getting a value of approximately 5.52 or 5.5 if we're going to the nearest tenth. And so your dimensions would be 9.6 by 5.5. You're going to use both of those answers in your final answer for your dimensions. Okay, so let's take a look at the next thing. So this here is supposed to have the symbols for triangle. It appears that I forgot to go back and type those in. So we have triangle ABC is similar to triangle DEF, and we are supposed to find EF, AC, and DF. So let's start first off by figuring out this missing length here. Okay, so if you guys notice, it is a right triangle. So the very first thing you would need to do is to do Pythagorean theorem. So 3 squared plus 4 squared equals x squared, which I already gave away the answer. Once you get this gets 25 equals x squared. So your x equals 5. So this value, AC, is going to be 5. Now, if you notice, To go from this triangle to this triangle, we can multiply by 3. So that's the shortcut. You 100% could use those proportions and cross multiply, but what we can do is we can then multiply each of those by 3. So you get 12 here, and if we multiply this by 3, you get 15 here. So again, we could set up the proportions to get that, or we could recognize that second triangle is 3 times as large as the first triangle. So EF is 12, DF is 15. So take a second. I'm going to have you guys do steps 2 and 3. So find the perimeter of both triangles. Go ahead and do step 3. Find your area of both triangles. So hopefully, as you guys did the perimeter of the first triangle, we'll do this one in red, is going to be 3 plus 4 plus 5, which gets us a value of 12. So the perimeter of the first one is 12 units. If we do the second one, that one is going to be 36 units. So 9 plus 15 plus 12. When you're doing area is slightly different. So when you look at the area of both of these triangles, notice it's 1/2 base times height. So the first one is going to be 1/2 3 times 4, which is going to give us a value of 6 square units. And then the second one is going to be 1/2 times 9 times 12, which is going to give us 54 square units. So here's the key, all right? If you look at this, and I'm going to do this here in purple so it kind of sticks out, the scale factor to go from the first to the second, or the second to the first, depending on how you look at it, your scale factor is 3. We multiplied by 3 to go from the little one to the big one. If you look at your perimeter, notice you are multiplying by 3 because a perimeter is a one-dimensional thing. It is a length. If you look at area, we are not multiplying by 3 to go from your area of your first to your area of the second. If you notice, you are actually multiplying by 9, and that 9 is actually 3 squared. So for your perimeter, you are multiplying each side by 3. For your area, you are multiplying by 9, which is really 3 squared. Okay, so think about it like this. If you knew you were multiplying the first one by 4 to get to the second one, so let's say, again, that scale factor is 4, your perimeter would be multiplied by 4, but your area would be multiplied by 4 squared, which is 16. Okay, so just kind of process that. We're going to take a look and use this kind of concept here with this one. And you're going to kind of hopefully solidify that concept. So when we look at this, given that you have 2 similar triangles, find the perimeter P and the area A of the smaller triangle on the right-hand side. So first off, what you're going to do is you're going to use this to get started. So you have 13 over 9.1. So the left triangle over the right triangle. We know, so I'm just going to put here in parentheses, left over right, so we can keep track. We know the perimeter of the left triangle. So we're just going to do our cross multiplying just like we have been doing. Okay, so first thing, 9.1 times 36, which gets us a value of 327.6 equals 13x. Divide each side by 13 and you get a value of 25.2 for the perimeter. Okay, when you're dealing with area, what you're going to do, much like here, to go from the area, you're using your scale factor squared. Okay, and so your scale factor here is this 13 and 9.1. So 13 and 9.1, and what you're going to do is you're going to square that. So when you do that, 13 squared is 169. 9.1 squared is going to give us, 82.81. So we're going to square that, and now we can go ahead and use area. And now we can go ahead and cross multiply. So when we multiply that by 60, we get 4,968.6 equals 169x. So then divide each side by 169, and you get a value of 29.4 for your area. So again, if you're dealing with perimeter, the scale factor remains the same if you go from one triangle to the other. If you're dealing with area, you need to take the original square factor and square that, because again, area is dealing with square units. So you have, again, you think about that label, that's going to help you. If area is square units, so you have to square. Okay, perimeter is not square units, so you leave it alone. So notice if we labeled this, this would be centimeters squared. This one would be just centimeters, okay? I can guarantee you that there are going to be questions pop up over this last 2 screens, so please don't hesitate to ask. As always, I'm ready and willing to help where necessary. Thanks, guys.